Yes, good morning, everyone. In the today's class of this industrial robotics, would like to deal with the topic classifications of the robot. Has been the robot functionality has been classified into two groups. That is, its configurations based upon its configurations and the capability of working area that will be coming under this work envelope, and hence within the particular geometrical specifications, that is in the global coordinate system, we used to operate the robot, and based upon the operation, the space that will be occupied entirely as per the desired extensions of the links based on the joints will be specified in its work envelope. So hence these two different classifications plays a major role in the functionality of a robot. First one is a robot configurations and its work envelope. Based on the configurations, the work envelope will be characterized. Yes, coming to the configurations, robot configurations. We are having four different major configurations in the functioning of robots. First one was the Cartesian coordinate system, which is having the movements towards the x-axis and movements towards the y and obviously the z-axis. So three different axes, and that too both in positive and the negative axis. Whereas in the cylindrical coordinate system, will be having either of the rotatory joint or revolutory joint. Clearly specifies one rotational revolutionary type of joint and two prismatic concentrations of joints in the case of this cylindrical coordinate system. And third one, it is an spherical coordinate system. It will be having of two rotatory or revolutory joints and one prismatic joint, present quite opposite to the cylindrical type of coordinate system. And as the spherical coordinate system consists of two rotatory or revolutory kinds of joints, indeed to exercise in its work envelope, and one prismatic or linear type of joint for its functionality towards its work envelope. Finally, the fourth one is an articulated coordinate system, or is the jointed arm coordinate system. It is having the entire rotatory or revolutory joints. There is three different joints are also three different parts of the joints also will be existing with an unitary kind of joints. Either it may be of the rotatory type or else the revolutory kind of joints. We all aware of these two types of joints, that is prismatic type of joints, or else the linear movement of joints initially, and secondary it is an rotatory type of joints, and third one is an revolutory type of joints. We all are very much familiar regarding these three different types of joints. Let me brief out one by one. The prismatic joint will be having its movements only in any of the axes directly. That is nothing but sliding towards the positive x or minus x, first one, sliding towards the positive y or negative y, and next even sliding towards the positive z or negative z. So hence, what all these three parametric synonyms has been taken place, we will be having 6 degrees of freedom. And we all know that for an universal kind of robot, we will be having 6 degrees of freedom. And coming to the point of this Cartesian coordinate system, we are very much clear that the robot has been configured based upon its movements among 4 different coordinate systems. That is the first one Cartesian type of coordinate system, second one is a cylindrical type of coordinate system, third one it is a spherical coordinate system, and fourth one is an articulated coordinate system or the jointed arm coordinate system. And the Cartesian coordinate system is again subdivided into transverse and gantry type of systems. Coming to the point of this articulated or jointed arm coordinate system is further classified into 2 groups. First one is some vertical movement and then horizontal movement of types. Let me check out individually based upon each and every configuration, and upon exercising the robot in the each and every configuration, what will be its individual work envelope. So work envelope in the sense, here is a clear cut definition, there is a workspace or work envelope. There's an extreme position of the robot axis describing a boundary for the region in which the robot operates. So when the robot is in complete extinction up to the end effector, we'll be considering the end effector as a major. And the work or the movements that has been exercised by this end effector within the axis or else surrounding towards its entire 360 degrees surrounding its environment leads to the work envelope, and the limits can be set off with respect to its configurations. For example, if the Cartesian coordinate system, in the sense only the extension of the positions will be taking place, will be limiting to a particular height or else particular length of its movements in different axes. But whether if you have been considered this articulated type of coordinate system, will be having all the rotatory joints only. In that, it may be inclinating, moving with its inclination to a particular value, either it may be of 45 degrees or 60 degrees, whatever the convenient position. And furtherly, the second joint is also, second link and third link is also getting moved or rotated. And finally, we'll be having a revolutionary joint. Throughout its surrounding, will be having the movement. And at that particular position, the heights, the extensions will be getting varied when compared to the Cartesian type of coordinate system. Coming to the in-depth of each and every type of coordinate system. First one then we are discussing, there is a Cartesian or rectangular type of robot. We'll be having 3 prismatic type of joints as we have been discussed now, and that whose axis will be coincided with an Cartesian coordinate system. So Cartesian is x, y, z, and 3 mutually perpendicular axes. And most of these robots come as gantries, which will be referred with respect to the frame structure that will be supposed to the linear axis. Linear axis in the sense the standard axis of x, of y, and next the z. So mutually perpendicular axis. And overall the values are the robotic position within the frame. If it is in 2-dimensional, the XY frame will be taken place, or else YZ frame will be taken place, or else the ZX plane will be considered. And will be having only any of the two values as per this axis. And globally, if have been identified the object in three-dimensional strategy, the end effector will be referred with respect to the X, Y, and Z also. These gantry robots are furtherly classified into special machining tasks based upon its special machining task. This will be utilizing for our water jet machinery or laser cutting robots where these motions will be cover large surfaces. And palletizing. So palletizing is a best action for carrying the material of a heavy materials from one place to the another place. So we will be called as a pick and place of kinds, and that too heavy loads. It either may be considering of within the working environment or from the production range to the warehouse zone. Next, warehousing. And in the warehousing, the materials are carried as per the sectional basis. So the coding, concerned coding will be guided, and related to the coding, those will be placed in particular destination points. That is related to the Cartesian coordinate system. And basically, we need to keep in mind that the Cartesian relates to X, Y, Z. And the movements, what are the types of movements that can be possible in this coordinate system? Three prismatic joints only. So how many types of joints in the sense in the case of Cartesian coordinate system? Three prismatic joints, prismatic type of joints. So we'll be having a detailed look and with respect to the working axis also. This is the Cartesian coordinate system. A robot. This is an X direction, positive X, negative X, positive Y, sorry, positive Z and negative Z, positive Y and negative Y, mutually perpendicular. See, this is one direction, this is another direction, completely perpendicular with respect to the X, Y is, and apart with it, the Z is completely or mutually perpendicular to the X and simultaneously the Z. Right? So the working aspect is also, if you can clearly observe, this is the link 1, and this is the link 2, and this is the link 3. The three different movements are existing, and one link is supporting on the another link for its sliding actions. Sliding actions. If you clearly observe here, L1, link 1, this link 1 is a supporting edge to slide this link 2, which is also holding the link 3 and end effector. And coming to the link 2. So from this bottom dead center to up to the top dead center, that is towards the positive Z axis, the movement will be considered. So one direction of movement has been considered to raise a particular elevation or height level. Second thing it is towards its Z. So when it is in complete contraction, there will not be having any of the extension mode. So if positive X has been taken place, by maintaining the sliding action or by mounting towards it, link 1, towards the extension position, the distance will be tracked. Next, if you have been observed this link 3, it is again mounting with respect to the link 2, mounting with respect to the link 2. The mounting and link 3 as link 2 base చేసుకొని వర్క్ అవుతుంది. Link 3 అనేది entirely depending on the link 2, and link 2 and link 3, which is directly depending on the link 1. So ఈ లింక్ ని బేస్ చేసుకొని link 2, link 3 and దానికి attached లో ఉన్న end effector అన్ని కూడా ఉంటాయి. So if there is any changes in this link 1, if this link 1 is lowered, link 2, the link 1 stud is lowered, simultaneously link 2 and link 3 also will be go to the bottom dead center. That's the main point we need to observe here. And if link 2, if link 2 changes its position, there will not be any movement in the link 1 because it is not directly depending on other two links. Only the other two links are directly depending on the link 1. So link 3, when you compare with respect to the link 3, if link 3 changes its position, there will not be having any change in the link 2 and even in the link 1. Directly only the link 3 will be sliding and the position of end effector will be getting changed. The position of end effector will be getting changed because end effector is attached to the link 3, and hence if the link 3 slides, then the position of the end effector also will be changed. These are the main points that need to be taken place. Here in this Cartesian type of coordinate system, there is no any question of inclination. There is no any practical inclinations here, and even the orientations are also not possible. Only sliding about the fixed axis in any of the link 1, link 2, and link 3. And hence the movements of the end effector is also will be in sliding actions only. And at the end, based upon the connected grippers, end effectors, either it may be the grippers or else the tools and different types of grippers, concerned actions will be getting progressed. So in the real-time basis, the work will be progressed like this here. Packing sections that have been considered and picking of the objects and next placing over here, and concerned actions. Seal will be getting considered here. Seal will be taking place. So this is the real-time sealing of a or packing. Will be calling as packing. That's the best example. And if you have been considered the workspace or work envelope related to the Cartesian type of coordinate system, this is the extension mode, complete extension mode. This is the link 1 is completely extended. That's z-axis, and next link 2 is completely extended towards the positive ex, and next completely extending this link 3 on the y direction. Hence this is the complete extension position. So complete extension position low the end effector position and it's a surrounding space which is occupied. So surrounding space here in the sense the rectangular position that has been having. So contraction extension position ఉన్నప్పుడు ఇట్లా వచ్చింది. So contraction వచ్చినప్పుడు completely the other end of the rod will occupy a space towards the opposite direction also. So hence we have to consider both the sliding movements, positive and negative, and hence the rectangular position is the work space or work volume. We will say volume, the amount of space occupied, volume. So the movements of the different types of links within the robot will occupy some space. So ఎంత స్పేస్ అయితే ఆక్యుపై చేసిందో దాని వచ్చేసరికి మనం వర్క్ వాల్యూమ్ అని చెప్పేసి అంటున్నాం. అండ్ వాట్ ఇస్ ద షేప్ ఆఫ్ ది వర్క్ space? What is the shape of the work space that has been obtained in the case of Cartesian coordinate system? Like one more bit. So what is the shape of the work envelope or work volume or is the workspace in the case of Cartesian type of coordinate system? So we have to write that a cube or a rectangle based upon its movement. So your option will be either a cube or rectangle. This is the 3D orientation of its work volume, the movement. Coming to the second classification, second type of classification, cylindrical type of robot. In this cylindrical type of movements, we'll be having two linear type of movements. Two linears of movements could either may be of x or y, xy, or yz or zx. Either of the planes can be considered, and we'll be having one rotatory motion. So here the robot's manipulator has one rotational degree of freedom and two translations of prismatic movements occurring in it, and hence degrees of freedom will be calculated based upon its movements. If you have been considered both the positive and the negative, obviously in the three-dimensional strategy we'll be having 6 degrees of freedom as a standard, and if it is furtherly any more degrees of freedom has been given, and it will be getting changed based upon its working environment. Degrees of freedom will be getting changed completely. A cylindrical coordinate system generally results in a large work envelope, nothing but occupying the more space in its working period. It's ideally suitable for pick and place kind of a robot, just picking the object from one place and next rotating to one particular degrees of inclination, either it may be of 30 degrees, 60 degrees, or 90 degrees. And next third one, it is an extension and unloading the object. Again, contraction and counter orientation or counter rotation, and next the again picking the object. So these will be the movement. And what are the different types of applications towards this cylindrical type of robot? In the sense, conveyor belt system is a good system, and palletizing. So palletizing and conveyor belt. So conveyor belt, we'll be seeing the example also. See here, this will be the configuration because of cylindrical type of system. See, first one will be having the orientational structure or rotation. Secondary, it's a sliding motion, stud motions, and third one it's an having extension position. So initially it is one will be having permitting in nature because this is a standard fixed agitation of the robot. So we have to consider the movement over the slick one. So it's a sliding motion. So in cylindrical coordinate system, we have been characterized two prismatic joints plus one rotatory type of joint will be taking place. Consider here first one sliding on the link one. That is the first prismatic movement. Second one is also extension or contraction over this link one, link two, sorry, link two. Link three is submerging piston and cylinder arrangement format. This is a piston which will be extending its position and contracting its position to the link two, right? So link three is an extension and contraction, and hence obviously the end effector will be getting taken place here. So hence three different motions, one rotatory or revolutionary motion, two prismatic motions of considering. Coming to the work volume related to the cylindrical type of robot. See the space that will be occupied. Here the rotational basis will be existing as a base rotation and extension towards a particular height from bottom dead center to the top dead center until, and next the extension will increase its work volume in both positive and negative, and for considering its positive and negative, bottom dead center to the top dead center one prismatic, and from here extension there is an opposite direction completely. So another axis is coming into the force. There is an considering y-axis, and there is an x-axis extension. So hence two directions, two prismatic movements has been achieved, and one rotatory aspect. So based upon this, the link 1 will be rotating, right? So link 2 is having the sliding motion, link 3 is having the sliding motion, and link 1 will be having the rotatory motion. So if link 1 is rotated towards the 30 degrees, obviously this entire link 2 and link 3 is attaching to the link 1. It is also rotating to a 30 degrees. Hence this position will be rotating to 30 degrees and enter the position will be like this. In this way, the rotation will be like this. End effector will be here. And this end effector will be placed to here. If the counterclockwise direction is taken place. If at all the clockwise direction towards a 180 degrees has been considered, clockwise 180. So clockwise in the sense, in this way, the rotation will be taking place in this way. From here to here it will be coming, and this is the 90 degrees and towards this 180 degrees. And similarly, this position will be towards the left side if 180 degrees has been taken place of its rotation. And hence, that will be the rotatory motion. And hence, two prismatic movements, one rotatory motion has been achieved. And upon its motion, this is the trace that is being generated, or this is the space that is occupied in the by the robotic end effector or tool or gripper that has been utilized in the place of end effector by the cylindrical robot is this one. Cylindrical. The name itself specifies this. The shape of the movement of this robot with two prismatic joints and one revolutionary joint will develop the cylindrical motion. Cylindrical motion is the traced motion. That is the major concept. And here also you need to consider that in the case of two prismatic and one rotatory kind of joints, upon its motion, what is the type of trace will be identifying as an output? Either it may be the cylindrical or is Cartesian or is the articulate. So you need to specify that cylindrical trace will be generating in its work volume. Here, coming to the third coordinate system, that is spherical coordinate system. Spherical coordinate system or polar coordinate system. This is another type of coordinate system utilized in the industrial sector for robots exercising, which will consist of only one linear motion and two rotatory motions. And in this rotatory motion will be having either inclinational factors or else revolutionary concepts. And here the first motion corresponds to the base rotation. Base rotation, that is link 1, stud will be rotating towards the clockwise or towards the counterclockwise. The second motion will be to an elbow rotation. This is the motion. First will be the rotatory motion towards clockwise or counterclockwise around the theta. Here in the diagram it is clearly specifying. And second one, this is the first joint, this is the second joint, and this is the third joint. And here also the theta, it is a pin type of joint which will be rotated in its inclination at a fixed axis. So elevation indeed increase or indeed to decrease. So if it has been increased simultaneously, this will be reflecting in a back theta minus theta, and hence the position of end effector which is attached to this link 3 will be it towards the height position like this. Entire this position will be coming into like this theta inclination. If this link 2 is a negative theta obviously the elevation of end effector will be like this in this way, right? Coming to the point of this link 3, we are having only the one prismatic kind of joint which is sliding to and fro motions will be created in the case of spherical coordinate robot. So hence our major motto, that is orientation or base rotation. Second thing, it is an rotation towards the pinhole joints. To consider the elevation for the end effector, and if the further elevation has been exercised with a slight inclination at different inclinational levels, the sliding actions need to be get performed, that will be exercised by this link 3 extension contraction. So two rotatory joints. This is first base rotatory joint 1, and here this base rotate this secondary joint pinhole between link 1 and link 2. That is joint number 2. That is also rotatory, and sliding motion for the link 3, which is holding in the link 2. That is sliding joint. That is third type of joint. So hence two rotatory type of joints, one prismatic type of joint is being considered in the case of our spherical coordinate system. So what is the workspace that is occupied by its operating upon its operation in the spherical type of coordinate system? So this is the spherical. So the movement itself exercises in spherical in shape. So throughout its movement, that is a rotation, rotation, and extension. In any of the functionality throughout its 360 degrees, if you have been observed the end effector movement or end effector trace, the shape will be obtaining is spherical. So this outer line frame in the diagram clearly shows the spherical shape, and hence the name itself exercise the spherical coordinate system, or else the other name for it is polar coordinate system. Fourth one, it is articulated or jointed arm type of robot. And we are also discussed that we'll be having of two different kinds of subclassifications in the articulated kind of robots. First one is vertical, and second one is a horizontal. Initially, we will be moving the discussion towards the coordinate system. And in the articulated type of coordinate system, how many types of joints will be existing and what type of joints they are? We'll be having three rotatory joints itself. And hence, for link 1, there will be a rotatory motion, link 2 also rotatory motion, and link 3 also will be in rotatory motion itself. We'll be seeing in the pictorial representation. First one, if you have been observing this articulated or jointed arm. So jointed arm means already discussed that there will be three joints, and three joints also rotatory only. Just we will verify in the diagram with respect to the diagram whether any prismatic joint is existing or not. See here, the base joint is the base, and this is the link 1. Will be having only the rotatory motion towards the clockwise or counterclockwise, only the rotation, and hence this is the pinhole towards it, and indeed to increase its elevation, just like as we have been discussed in the spherical type of coordinate system. But you said that the spherical type of coordinate system, so this type of joint, ఇక్కడ వరకు ఒకటే first the and second one, ఇంతవరకు ఒకటే ఇక్కడ కూడా articulated system level. See, verify here. That is being mounted here on the base. So first rotatory, base rotatory, and second one is also increasing its elevation. So indeed to increase its elevation, that is also theta in theta degrees. So basically it will be in downward stream. So downward stream లో ఉన్నప్పుడు 0 degrees ఉంటుంది, 30 degrees అయితే will be leaving here. And if you have considered the existing robot, it may be having the 60 degrees of theta. So this is the 0, and from here to here there is a 60 degrees, and hence next joint is also the rotatory joints. So here also there is a rotatory joint itself. See the direction clearly specify the rotatory joints. So this is the rotation here. So if the counterclockwise has been taken place, this entire link will be moving towards the upward direction, that is elevation upward directions movement. అదే ఇక్కడ clockwise కనుక movement జరిగితే will be coming towards the downward stream. So counterclockwise will increase its inclination from 0 to certain elevation, that is it may be of 30, 60 or 90 up to the 90. And if clockwise direction takes place from 90 to 60, 30 and next coincides with respect to 0. Simultaneously this joint is also, this is also the rotatory joint. This also indeed to increase its elevation towards the upward direction. This is the link 3, and this is the end effector which will be connected to the link 3. And presently we are not discussing related to the end effectors. Already in the previous class we have been discussed. So you need not to consider this end effector, just for the sake of pictorial representation we have been done. And you neglect or you omit regarding this end effector. This is the link 3, and its movement is also towards the counterclockwise అయితేనేమో height increase అవుతుంది, and towards the clockwise అయితేనేమో will be decreasing in its height. This with reference channel, right? And again we need to capture the work envelope. Coming to the point of the work envelope, towards the vertical articulated system. See, verifying here, one will be having the rotatory motion towards its base, and towards its base either, that will be here. From the top view, if you have been verified, there will be theta from this side to again 180 degrees this side. Other 90 degrees either, this will be the position. So if it is the position, 90 degrees will be the position like this. 90 degrees orientation, this will be the position if you have been observed from the top view, right? See, verify this once. This is one. So this, if this is the link existing, upon rotation from this frame to, it will be entering into this frame, from this frame to back end frame, like this. So upon this 90 degrees it has been rotated towards the counterclockwise direction, and this will be the traced position of links, other links attached to the robot. And coming to the link 2 and link 3, link 2 rotatory joint, link 3 would rotatory joint. So elevation increase avalana decrease avalana, this is the theta 2 variation. This is the theta 1 first one, this is theta 2 second one, and this is the theta 3 for third. All right. So 3 different joints are also the rotatory type of joints. Coming to the point of this horizontal kind. In the, this is a special case of robot will be utilized in some of the working units, that even though it is an articulated type of robot, in the case of this horizontal condition, so we are aware of this articulated kind of robot, again subclassified into 2 types. First one, it is a vertical mode. So this is an vertical mode. In vertical mode, complete 3 joints are also rotatory joints. Coming to the point of articulated or jointed kind of robots, in that subclassification, second type, it is an horizontal type. In this is a special type of articulated robot, will be having 1 linear joint and 2 rotatory joints, which will be similarly equal to the polar coordinate system. That's a spherical type of coordinate system, right? Spherical type of coordinate system. Third one, polar or spherical. Just will be having a detailed look once by sliding the slides towards the back. Then this is the spherical and polar. In spherical also, we have discussed clearly that one manipulator is the spherical or polar, one is linear type of motion having joint, and 2 are rotatory type of joints. Simultaneously, in this, both articulated, that too in the case of This horizontal will be having two rotatory motions and one sliding motion, which will be equivalent in its operation with respect to polar type of coordinate systems. Also, this the another name for this articulated system is a SCARA robot. What is meant by SCARA? Selective Compliance Assembly Robot Arm. So here robot arm in the sense each and every link we need to select. So that links assembly will be of our choice depending upon the work it has to perform in the industry. ఏ type of work అయితే perform చేయాలో and that type of work based upon that designs we will have the assembly with different linkages based on the type of joints by selecting the type of joints based on the output work. Here, if you have been seen clearly the observation towards this, see this is the best example. Initially, the position is like this. So contracting and extension. Here, this is the base, first rotatory joint, and this is the link to second rotatory joint here, and this is the link 3, right? Will be having the extended position towards this. There are sliding actions that is being considered in the case of this one. First one, the link is rotatory link. Second one is also rotatory type of joint. See, and in the link 3, we are having the sliding movements. So the sliding movements in the sense towards the negative y-axis and towards the positive y-axis. And this object, upon rotation of this entire equipment, will be sliding to another position. That work envelope also will be verifying now. And this, indeed, to pick the object from certain elevation, the extension will be taking place, and after holding the object, again it will be coming to the contact point. That is the actions that will be considered in the case of this articulated kind of robot, particularly in the horizontal kind. The type of joint will be varying. We have to remember this. In 1 mark bits also they will be clearly asking these type of questions only. How many types of joints will be existing in the case of articulated kind of robots, especially in horizontal mode. So hence we need to specify articulated anandane will be noting that 3 different types of rotations, rotatory type of joints will be existing. But particularly he is asking in the question that in the articulated kind of robot, subclassification towards this, either it may be at the vertical mode of working or horizontal mode of working. How many types of joints will be existing? What are the types of joints will be existing? So 2 rotatory and 1 revolutory or rotatory. Sorry, 1 prismatic joint will be existing in the case of articulated kind of robot, especially in rotating in its work volume, especially in the horizontal mode. Other vertical mode అయితేనేమో articulated kind of joints లో. The best example is our crane, which will be lively visualizing in our daily way of life. 3 different joints to the rotatory type of joints and rotatory type of joints in the case of vertical move. Right? You have to clearly verify. See, in the Cartesian coordinates, x, y, z basis, and cylindrical coordinates వచ్చేసరికి ఒక rotatory joint and 2 prismatic joints, y-axis, z-axis movement. Base rotation ఉంటుంది, and next region, breadth and height. Spherical coordinate systems lo, this is a complete vertical. Here we will be having a theta orientation and 1 prismatic movement and beta orientation. So 2 rotatory joints and 1 prismatic joint in the spherical coordinates. And articulated lo again 2 different conditions ఉన్నాయి, vertical condition and horizontal condition. So vertical condition lo వచ్చేసరికేమో rotatory theta, again rotatory beta, again rotatory gamma in the case of vertical. అదే horizontal లో అయితేనేమో will be equal to the spherical coordinate, that is ఫస్ట్ ఏముందంటే theta ఉంటుంది, and next again the rotation ఉంటుంది, and third one is will be the prismatic any of the x or y. Clear? You have to clearly remember regarding this, right? Next, based upon its movements, the exercising, these are the advantages and disadvantages related to it. Right? There is a basic difference between this. Okay? And these are the different types of classifications existing in the robot. Okay, thank you. We'll be meeting in the next class.